Whoever builds a compiler that produces the smallest bundle would most likely win the bundler war, regardless of how developers feel about it, or if they say, oh, well, they love this ecosystem so much. That doesn't matter if you can produce 50% less payload.
Hello, welcome to devtools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. We're really excited to have Zack Jackson back on the podcast with us. Zack, you were on, it was like episode 30. We're like in the hundreds now, so it's been a while. So excited to have you on. And we know there's a lot that's changed with you. So previously when we last talked to you, you were working at Lululemon, and now you're at ByteDance. And so if anybody wants to go back and check out episode 30, we talked a lot about some like really interesting work you're doing at the time, and I hope to get some updates on that. But before we dive in, would you like to update our listeners and kind of tell the new listeners like about yourself and like what are you up to these days?
Yeah, sure. So I'm a infra architect at ByteDance, and what that basically means is that I work on like a lot of our infrastructure tools. So obviously the company is really large, so there's a big set of problems that is never ending to solve, and yeah, and so essentially I think our team with about 60 members on the infrastructure team, and so it's about 60 of us, and on infra we pretty much deal with everything from like building out custom runtimes, so like custom JS runtimes that comes out of our kernel team, native frameworks and renderers for various things, compilers, obviously JS frameworks, and then other, things in between, like just the tooling to get stuff from A to B. So yes, that's a lot of what I do day to day, which is essentially what I've just always been doing, but now like at a much bigger scale, which is quite nice. And then obviously Module Federation is still like, very close to my heart. And luckily I happened to land at the company who happens to be the largest user of it out there. So it all worked out well.
Yeah, it seems like ByteDance has created a lot of different things. Just from the outside looking in, there's like a lot of innovation going on and like next generation type tooling. So like when you first started, like what attracted you to the company and what projects at the company have you gravitated towards?
Let's see. Okay, so I guess like a thing that I usually look for at a company is like, I'm always about like impact. I know that's like an overused word these days. But like generally if I have to go somewhere and I'm just pigeonholed into cool, well, like you'll do this. This is kind of why I got out of product engineering, is it was just not high impact enough. And I think after a while, it's also very dependent on like the health of the organization, how enjoyable it is to work on the product actually becomes. So in some places it's you're very beholden to changes of like non-technical users, which can be difficult to kind of like really get in and get things done. So I would say the main reason what kind of attracted me was just really the size of the issues that they had, and the fact that a lot of the problems that they were looking at were really similar to things that I had been interested in solving. And I think ultimately it was kind of like, okay, well, like when I was looking around at the opportunities, and then the kind of just the numbers come out of like, hey, well, here's the size of the people that use this stuff, and here's like the runway of problems that you can have to solve here. And that really kind of hooked me in the end. But how it kind of started was, it turned out ByteDance had been after me a couple times, and I just didn't remember. Apparently I had like a call with the previous infra team manager before, and I don't know like why I didn't end up going there or what the deal was. But so what ended up happening on like about a year and a half later or so, how we actually started like getting involved was, I was trying to replace Webpack's ES tree parser with SWC in like a desperate search for to make it faster. And obviously I knew nothing about Rust at the time. So I'm like, hey, how do I get like the Rust back to the JavaScript? Like, the most basic thing, like just how do you like get it back out? And so I'm fumbling through, asking around online, and someone's like, "Hey, yeah, I can help you," and jumps on a call with me, and so we chat for a little bit, and he unblocks me, and then we're going back and forth over just like as I uncover the problems of why this ultimately is not going to work. Um, uh, and who I ended up speaking to was actually the lead of rspack, and I just didn't know it at the time. So we're kind of going back and forth, and he's watching me like fumble through, like failing trying to make Webpack faster with some Rust. And then things kind of die down, and then maybe like a week or two later he just messages me. He's like, "Hey, I want to show you something." And so I get on a call, and they're like, "Surprise, there's this thing we've been working on where we actually have ported Webpack into Rust," which obviously I was very skeptical about because I've heard this song and dance many
Yeah.
a time before. And, my general assumption was you can't like you can't really do it. Like for the surface of the API that it gives you, that's just not something that you can create in native, because I haven't seen anything done in like, in any of the other native build tools that have like an API on par to something that's just stays in JavaScript. So, he kind of took me through it, showed me actually these are the real loaders and are the real plugins. We didn't just fork this. It doesn't just look like Webpack. It's actually running their ecosystem without a problem. And I think that was probably the main thing that hooked me into coming in, was like, okay, this is real. Like for all my involvement in Webpack and like how much I've been like, a fan of it and how it's helped my career. Obviously, when like the Rust Webpack pops up and it's like, okay, well, I feel like this would be real good. And then on top of that, I found out, they use a lot of federation here. So, there was just like, cool, I get to work on the thing I like to work on already, just in Rust and faster and less constraints because we would actually own the product. So, it was just, that's really kind of what attracted me. Cool. There's really big problems to solve here that usually you can't really get solved unless you just have like unlimited resources to throw at the problem. And that's really, really difficult to come by. And luckily, just because of like how the company is, because it has so many products and so many different like offshoots of various things, um, a lot of the architecture attempts to be unified. So then that means it's like, okay, well, you need a tool that's going to be able to do like 200 different, business cases that are, vastly different. So just, it was kind of cool because it wasn't as fragmented and disjointed as like you would usually see, where things kind of pop up around an organization for, hey, what works there? Which, I mean, that's totally fine. But I guess like it's one of those things where I think economies of scale really kind of help. And I like working in the areas where economy of scale is useful. So there were a lot of things here that just made it yeah, I'd love to come and work here.
Big thanks to WorkOS for sponsoring this episode of DevTools-fm. If you're building a SaaS and thinking about moving up market, WorkOS gives you everything you need to make your app enterprise ready without turning your roadmap completely upside down. From single sign-on and directory sync to audit logs and fine-grained authorization, WorkOS is packed with the features that companies expect and developers can actually work with. What sets it apart is how modular and well-designed everything is. You don't have to use everything at once. Just pick what you need and drop it in. The APIs are consistent. The SDKs cover all major languages. The developer docs are genuinely some of the best out there. And if you're dealing with onboarding flow issues or user management headaches, WorkOS has solutions for that too. A pre-built admin portal, secure credential storage with Vault, domain verification, and a whole lot more. It's built to scale with you, whether you're closing out your first enterprise deal or rolling out compliance features before the questions start coming in. So if that sounds like something you need, check out WorkOS at workos.com. Let's talk a little bit about Webpack. So it's like, it seems like for a little while, at least in the realm of like Twitter and Blue Sky or whatever that I'm on, like a lot of companies and a lot of people have been talking a lot about Vite and its sort of shape in the ecosystem. And I know that there are still a ton of companies using Webpack. And I know some folks and places that I used to work that are still using Webpack, but like you definitely don't hear as much about it these days. And I'm curious, like, how do you think like rspack is like changing that? What are you sort of doing fresh and new? And like, how do you see it fitting in the current ecosystem?
So I guess I don't know. I personally view them as like two different categories of tool, to be honest. Like, and nothing against Vite, just in its current form, I know that it can do the job for many developers, but uh, like I don't know. I guess like, well, why doesn't Next.js just use Vite then? Like, why does TurboPack exist? Like, I'm not trying to throw shade here, and maybe like I just got off a very long flight, so. But if it's the be all and end all, then then nobody would be building TurboPack. Next would be using it, and blah blah blah. But it's not, and that's nothing. Like I mean, nobody uses CRA to build out these crazy type of things, and there's various use cases for them. I think Vite really, why Vite got so momentously popular, just speculating here, is configuring build sucks. And nobody cobbled a solution to that together. You had Webpack, which was okay, it's all into one, but then you also have like, a PhD degree in configuring Webpack to go along with it. So over time, and then it's something like ES build pops up, and it's like, oh, cool. Here's like an API with 4 hooks, and that sounds fantastic. Because if what you want, when I think of ES build, I always kind of in my head kind of put it as, oh, I need fancy Babel. Like I need something that mostly just transforms things and kind of puts it in certain places, and that's about it. Like a little bit more than SWC, but fancy Babel. Transpile things, pack it into simple files, and off you go. So I don't know. I kind of see like what Vite had done, and we had learned from this as well when we saw what they had done. But they got super successful because if you weren't using Webpack, then it was like either rollup or ES build or some kind of Frankenstein between the two or whatever. And so what Vite did was say, okay, well, and they introduced this thing of like a build tool. I don't think we had that really. Like, I don't know. I really only use Webpack, so I didn't go hunting around. But we didn't really have something like a Vite type experience that was just off the shelf to use, where, hey, here's a React plugin, and it's not you like configuring the loaders, but there's like middleware on top of that's instrumenting the tool. I think that really helped a lot in its popularity because config hell was real, and also it was just faster because unbundled, Skip's doing a lot of the build up front, and back in the JavaScript based tooling world, that was a big issue. Now, I would say on the flip side, though, it hasn't been all like sunshine and rainbows from like, and again, I just know from like the research that I do on these bundlers and from like what users tell me. So I'm mostly just kind of parroting like the things that I've heard or think. They might not be totally accurate or whatever, but like I think a big one that we can probably all understand is like, okay, well, the development versus production discrepancy. And so I mean, that's not a super bad problem. It's something you can work around. Like either way, like it seems to have not impacted the community to a detrimental point. The problem is though, is I don't see a lot of people putting like $500 billion company and betting it on that consistency being good. And this is something that I would say like Webpack has historically done well. It's had good artifact integrity. It bundles really small. It supports lots of things. It kind of meets you where you're at. And I think like when you're looking at the tools that you want, when you're on the lower end of like the problem surface, when you're let's say like when you're in the 80-20 rule, in the 80, you have a lot of options, but in the 20, you don't have so many. Like example, okay, if you take Next.js, well, Next.js can't just use ESVille or just use Vite. Like, I mean, maybe if you rewrote it from scratch, you could get all the things in there, but they could do that easier with just like TurboPack or Webpack to kind of do the role. But these are also some of the more sophisticated like build needs out there where they're doing a lot more crazy stuff. So, I think there's just kind of a difference between the target markets of what we're looking at. There's, like I would usually say that probably these are an acquired taste, but our target market is obviously everybody. We'd love for you to use the tools, but our focus primarily is like the focus we have here at home, which is, okay, you've got a $400 billion business and everybody uses these things and it needs to scale. And like your compute costs are like, it's at the point where you're looking at engineering is cheaper than compute. So CI taking long and chewing up boxes the amount of manpower to just write a new compiler is cheaper than living with the boxes taking 40 minutes. And if you can do that, plus artifact integrity, all the other things that you want, we were just in a position of why not go and do it. So, ultimately, I think the two will live side by side. What I think really needs to happen, though, is like with roll down. So that's kind of what I'm excited to see, like what's going to happen there is because I think a lot of the problems in Vite, it's also kind of unfair to say, oh, well, I see some users use it as scapegoat. Oh, well, it doesn't do this, that, or the other thing. And yeah, sure, but they have a thing that they're working on to bring out. It's just not out yet, which, again, we'll see what happens when it comes out. But I think when we're in that space, what we've also noticed that was interesting is that Vite seems to be like looking at the bundled mode for apps. So instead of doing the bundleless and dev like it's always done, they're looking at adopting some kind of like proprietary Webpack-esque chunking format and some kind of runtime for it. And I think that that's a really good move because at the end of the day, I think like the whole idea of unbundled ESM, I think everybody has tried it for a while and it kind of works, but there's like problems with it that aren't necessarily on paper problems. Like doing everything unbundled, it's technically going to work really well on your machine in incognito mode. But go get the user machine with like the 6 Chrome extensions and the Bing search bar. Like you remember the old IE where you'd have like that many toolbars? Like, imagine a browser that's got like that, like your average Chrome, like extension laden browser. And then if you have to download like, 4,000 little modules, it's not, your network isn't the problem. It's all the junk that's sitting on the client device that you can't benchmark against that like brings it down in the real world. So I think a lot of these things seem to be going in the right direction of, hey, we tried various things. We think a bundled mode would be good. And the reason that we can do a lot of this stuff is like we have faster tools so they can do more work. Like, cool, we can bundle it all really quickly and make it, more or less as fast as like unbundled, just because like Rust would enable speed where, if it takes like 300 milliseconds to start up, we don't really care at that point. Like it's beyond the point of caring. So I'm also excited for us to get that because it seems like everybody in the bundling space is kind of getting to the point where speed isn't going to be like this thing that the bundle of wars are fought over, which I feel for like the past 2 years that's a lot of what it's been. Oh well, which one's faster or so on and so forth. But now it seems we're talking about like, oh well, this one did it in 1 second and this one did it in 600 milliseconds. And it's like, okay, sure, that's still maybe, 2 times faster or whatnot. But then when you look at the demo app and it's building like, 15,000 modules or something, you're like, okay, well, realistically, yeah, so there could be a scaling issue. But if you can build, I don't know, like we have one here that's like, I think 50,000 modules. It's like, okay, if I can build a prod app of 50,000 modules and I can build it in 20 seconds, then, that's probably the slowest build rspack has on the market. And that seems more than acceptable to us coming from, that taking like over an hour or more to build. So I think as well, just like the focus is going to start to shift as we all get the tools where it's fast and where it's like, okay, well, a little like when you're doing HMR, if it takes 100 milliseconds versus like 85 milliseconds, nobody cares at that point. It doesn't take 15 seconds to see the update. So I'm hoping that the speed war kind of changes. But then again, I don't know what the next thing will be that the bundlers are kind of, vying for. Anyway, long-winded response, but that's just kind of how I see things. I think there's a place in the market for 2 and or more. And at the same time, like now it's more become like, well, what ecosystem do you want to buy into? Like which one has the parts you want? Vite has a big community, a big type of ecosystem, and lots of people like using that. But there's also people who, enjoy the Webpack type ecosystem. But usually because it's like, oh, well, they're very familiar with loaders, or there's certain APIs that let them do certain things that are just easier to get done in there, or, whatever other reason, just that's their flavor of the month. Then it's kind of nice to say, okay, well, this becomes more of a preference choice than not like well, like what's the real big difference here? But I think what we'll just see is there's going to be, just like you have React and you have Angular and you have Vue, you're probably going to have like, cool, they're all going to more or less do the same jobs that 80% of the users need. And then it's really just, well, what do you like using to do that job? Or what does it integrate with that you might also want?
A lot to dig into there. So one of the original goals of rspack was kind of just to be this drop-in replacement for Webpack and to like completely support the API. That works in the beginning, but as you said, new things are gonna be unlocked. So like what has rspack like worked towards that's kind of like innovations on top of Webpack rather than just like matching the old API?
Okay, so I guess to go back a little bit as well for some context on why we went this route. So we didn't just like go, let's port Webpack, and that was the plan. That was the last thing that we did. So we have like pages and pages of documents. I think there was something crazy. I think like people from ByteDance have worked on every Rust bundler except TurboPack, as far as I'm aware. So most of them that are on the market, like in some way, shape, or form, some origin story can be traced back to that person's time working here. So there's just a ton of knowledge in building these Rust bundlers, and like 60% of them came from people who had started working on those here, maybe left and took it further, whatever. But like there was a lot of like catalysms here around bundler research and doing this. So the big thing that we have discovered is writing a bundler is actually not as hard as it sounds. The real problem is the API design and how that ends up biting you down the road. So when we started, we actually were like, okay, well, the first version of rspack actually was ES-build, and we rewrote ES-build. And so at a time, we were thinking of calling it GoPack, and it was going to be written in Go. The problem with Go that we found is it doesn't do well with bindings to JS with like very complicated bindings. Mostly like you have a garbage collected language to a garbage collected language, and that doesn't play so nicely. So then we kind of looked, okay, let's look into the Rust side of it, moving ES-build into Rust, and let's just fix some of the problems ES-build has, because it was almost, good enough for what we needed. At the time, we were just building our Lynx apps with it. So we needed it was originally called Speedy. So we needed a speedy solution for Lynx. And that was, hey, ES-build can almost do the job there, but if we could just fix these issues, perfect. What we ended up finding, though, is like there were bigger challenges in like ES-build, for example, like if trying to fix the code splitting so that it chunks the code better, or HMR. There's like architectural challenges that make that not just easy to add. Like the dev just doesn't want it in there, but it seems to be like, well, there's fundamentally it's a little bit trickier to try and do that. So we kind of ran into this wall a couple times where it's like, oh, well, let's try and create something new. And then it's like, okay, well, then there's the explosion of what ifs that come in that haven't necessarily been thought through, and it's uncharted territory and so on. So we had two main issues. One, we had a lot of things using Webpack. We were also investigating Vite at the time because Vite was getting popular, and we were like, hey, maybe we could switch over to that. And maybe that could work. And so then one of our infra teams ended up building, I don't know if you guys know farm.fe. Have you heard of that bundler?
I think I might have been on the page before.
Yeah, farm.fe. So anyway, so farm actually started out as ploy. So our infra team was split into two sections. One half of the infra team was building rspack. The other half of the infra team was building ploy. We reorged, folded the compiler teams together to reduce redundancy, and then I think the main guy behind ploy left the company and released farm, which was like which is essentially like from all the work that they had done in deploy, packaged it up and put it out there. And from what I understand of ploy was the idea was to have like almost a Vite type compatible API, just very quick, and solve the problems that we were impacted by, that there was no world out at this point. So this was the way that, they were going out to solve it. So we wrote like, I think maybe 5 bundlers in total, like getting through to this point. The reason we ended up on Webpack is, again, design issues. Oh, well, we can extend it here and there, but then like there's all the unknowns and race conditions coming in, which essentially just makes the risk too high to look at. So what we thought is, okay, well, probably the easiest solution would actually be to take something tried and tested that we know is guaranteed to work for all the business cases, and that was Webpack, which is a lot more complicated. But the nice thing with Webpack is it's also got over 10 years of testing behind it. And so it's pretty solid to start with that. So if we could port Webpack into Rust and say we have a foundation that we know has 10 years of like, here's all the things, it all works, it's all very well tested, then we could start to enhance and iterate on it, knowing that we actually have a stable replica of a powerful bundler to begin with, which is a lot less complicated than trying to design one that could be that or more in the future. So 2024 was largely get parity, get stability with the APIs. Like a lot of it was speed doesn't matter. It's about artifact quality and making sure we have like a 1-to-1 or, make sure it works safely. Like make it safe and then make it fast, essentially. So in 2025, now we're looking at speed opportunities. So I would say like things that we've been considering as like, time is going to evolve on. So there's a bunch of like various things, but we're quite interested in a lot of what the TurboPack team has been cooking up, and so we've had a lot of those plans in our plans since like mid 2024. So things like remote caching, function level caching, cache that you can share between different developers. That's something we're very interested in. I think we already have like function level code splitting as well, so you can move single functions out of chunks. Which these aren't, super, like most people don't really care about those type of like minutia, but basically it means you can make like a lot more fine-grained implementation, and a lot better code splitting, tree shaking, stuff like that. Another big area though that we want to look into, I think we've already started the work, but is going to be into a unified build graph. So essentially saying I want to build to an edge worker, a native device, a node server, and the browser, and I want to do it all from a single build, and then I want certain imports in that build to remain under certain boundaries. So like building the whole module graph that could control potentially 3 to 4 layers of your deploy stack, but it's understood as a single system to the runtime. So this is something TurboPack has also been working on. So what I would say probably is a lot of the future things that we would consider is going to be, we started with aligning to Webpack, we have a stable core, then now looking at things like what Turbo is doing, how can those be incorporated? Because we think a lot of those problems, again, are things that kind of align with the problems that we would like to see solved. Some other areas, though, like, a kind of an interesting one is, like, there's still a lot of room in tree shaking and dead code elimination. Like, my personal opinion has always been whoever builds a compiler that produces the smallest bundle would most likely win, like, the bundler war. Because regardless of how developers feel about it, or if they say, oh, well, they love this ecosystem so much, that doesn't matter if you can produce 50% less payload to the end user. Like the user wins, and if you can serve them twice the lighthouse score, like the business will override any engineering just because of like depending on the industry. But that's what I would say. If you can produce a smaller artifact, all the other points are moot. Like everybody's going to go for smallest thing to ship to user, best experience. At least that's how I kind of think about it. But tree shaking and dead code elimination is really tricky. However, most modern bundlers still leave about 40 to 50% dead code even after optimizing. So that's how much still could be done. And so one thing we've been looking at as well, we've been working, I think, with KDY on some of this too, but looking at how could we use dead code elimination and tree shaking by using the TypeScript syntax to help inform the bundler of what's going on. So usually when you build things, how it works is you take your TypeScript code, convert it into JavaScript, pass it to the parser reads it and does whatever. So you lose a whole bunch of things like, oh, well, if they were private, if this class is private, you could check, well, is that method actually used in the implementation? If not, we know that outside you can't use it because it's marked as private. So it's safe to tree shake if we don't find any inner graph linkages. So I think there's a ton of information like that we could extract, which would really help with like how a bundler can understand the app using like a better syntax or, a more informative syntax. Some other things that I know we've been playing around with was we had the idea of being able to use hot reloading to redeploy production. So HMR was designed for production use, and nobody really did that. So something that we've been looking into, well, is imagine if you need to perform like certain hot fixes. Instead of having to redeploy the entire code base, what if you could just push the hot update chunk into an existing app? So if you just needed to add the patch and the patch was only 1 kilobyte, you were essentially just pushing an extra KB into the existing app, and all your users could get it, and you could hot reload them, not preserve state in the browser, but you could effectively do things like that where your deployments just become hot reloads to the pipeline. So those are probably some of the more interesting areas. Then I know we're also getting into like stuff with AI and other things like that. So what I kind of see is potentially somewhere down the line where these things kind of like mash into something like combined, where you essentially have like a environment that's been custom built, and then potentially we could bolt on some kind of like agentic system to it, and we have a doc site system that's designed to be parsed by like a indexer for like a question and answer bot, and you would be able to have a code sandbox because we have like essentially we have enough of the loose parts where we could probably do some more interesting things like that. I'm personally quite interested to see. I know we started on it, but like MCP, for example, hooking up our build doctor, rs doctor to MCP servers, and now your AI would be able to understand what's going on in the build. And what if that could go a bit further and you had like some knowledge graph? So like the compiler helps serve, here's the application, here's how it's working, and potentially kind of, starting to utilize the bundler almost like as a language server of sorts, to find context and understand relationships about like manually splitting chunks and doing things like that. I think a lot of problems that you have in like AI and in like RAG is very much the same thing as bundler. It's just you're serving a different type of module back, which is like a text chunk versus a script chunk. But yeah, so there's some kind of interesting things that I could see floating around here. But I think in general, a lot of it's going to be on how do we make it, faster. Like I think mainly the big things right now are speed, improving the unified graph structure, because that would open up doors like RSD and other areas like that. And so something we've also been kind of considering is, what if like something like RSD wasn't bound to React? But what if there was like a bundler level protocol of some kind that fits within, that kind of paradigm? Because if you have like a unified graph and you can build the server, build the edge, build the browser, and the build is aware of where every part is going to be going, but also the runtime is aware of it as well. So the runtime could know that, hey, this is a server module per se. But what if you could kind of bake that into, well, this is just how like importing certain code works, rather than like, oh, well, here's React server components and you have to pass it props. But theoretically, you could do the same thing where you say, hey, here's bindings to a function that you get on your end. And those bindings are going to translate into a network related call or a call to a worker, and then get decoded on the other end. Kind of using a similar kind of principle as like what RSC would do. And I think particularly for something like Lynx, that would probably be very useful, because we already have this use main thread, and like using the background thread, you do parallel like multi-threaded processing on there. And so being able to do that more sophisticated without needing to kind of glue certain parts together, I think, would be quite interesting. I think this is where it would be nice to say, oh, well, Lynx already uses this thing where it's kind of like RSC, but it's built into like Lynx itself. Now, what if like the bundler itself had like a universal way to handle this problem of like, here, communicate with resources that might not be here, but to you, they feel like they are.
This episode is sponsored by Mailtrap, an email platform that developers love. Go for high deliverability, industry-best analytics, and live 24/7 support. You can get 20% off for all plans with the promo code devtools. Check out the details in the description below. Yeah, Lynx is such an interesting project, and I think thinking about the bundling scenarios there is like really interesting. This is something that we want to talk more about in a second, but before we move on to that, I would like to ask you a little bit about like, just recently announced a next RSpec module and like kind of moving into the Next.js ecosystem, starting to support that. And this seems like sort of like an alternative. So if like your team's not using TurboPack or not ready for TurboPack, like you have this alternative. Can you talk a little bit about like the work behind that, like how that came about? And the introduction post mentions like some collaboration with Vercel on at least like fundamentals. Is like, what does that look like for y'all?
Yeah, so yeah, I think it kind of, I think it kind of all jump started a little bit when about, I don't know, like 7 or 8 months ago. Well, whenever I was in China, uh, we were kind of looking for, hey, what should our plan be for like the next year? Kind of doing like mid-year planning, trying to think about like a bit, midterm, what our roadmap's going to be. Um, and so we're all sitting around the table, like putting out ideas. We had things like RS test, which is now kicked off to like all, RV test, but like integrated within like all of our other tools. And so we're going through the list of like things we want to add to the ecosystem or change, and then sarcastically, I just threw out RS next, and I don't think sarcasm translates super well. So everybody was like, oh, okay, that's would be interesting. And essentially what it ended up being was like, oh, well, we've tested at rspack on virtually everything we can find. Like we just clone down repos, see if rspack can build them, and that's kind of how we've like tested a lot. But the one we couldn't test was Next, because like you couldn't just clone it down and replace Webpack with rspack and you're good to go. So then we decided to try it. And so we forked Next, and I think it was like we went out like over dinner somewhere. We like went out for an evening and we're like, okay, let's just mess around a little bit, like over a steak, and just see, what we can get it to do. And so, within a couple hours, we got, Pages router working. And of course, not all the tests were passing, but it was like, okay, I could pick, a series of random tests and like, a basic page router with some CSS and, a couple other various things would work. And that was quite impressive to just see, oh, wow, okay, like it wasn't that difficult, and a lot still doesn't work. But the fact that you could get like maybe 40% of tests passing, or, something like that from just quickly trying it out to see, hey, could it actually build this? So ultimately, I think like the challenges that we had with that is, hey, this is really cool, and I hyped it up far more than I should have, just because I was so excited to see it. But the thing is, we didn't have a use case for it. So for maintaining a fork of Next is like a tall order. But it was really cool to prove that, hey, the bundle, like for us, it was, can the bundler do the job? If it can, then like, cool. I think we're hitting the right track when we can build what. Because Next is just the most complex Webpack plugin ever created. And that's Next.js with some server thrown in there. But it's essentially like, the GOAT of build plugins out there. So it was the perfect test case. So anyway, we kind of built that and shelved it for a little while. We a few people after the RS Next thing went out, I think a couple of people from Vercel kind of reached out. They're like, hey, what's your plans with this thing? And we're like, it was just kind of like mostly for testing. Like, we wanted to see if it would work, and it did work, so that was the end of it. And they would ask like, if would you consider upstreaming this, because it'd be great to like have another option. And hey, I think a big challenge Next has is they're not necessarily closed off to like other options being presented. The problem is like people aren't just on tap who can just quickly drop out a new a brisk replacement of Next.js's whole build infrastructure with something else. So I don't really think it's been a case of like, oh, well, Next is really closed off. It's just, well, how many groups are out there who are just going to like, well, one, know how to do it or what to do. And like, two, like, just, it's complicated to do. Like, so yeah, when we had something that was partially working, we started the conversations with them, and, it kind of like died out and came back and died out and came back a little bit over time. And I think ultimately, like what we had found is there would be really nice symbiosis here, because regardless of if Turbo competes with rspack or, whatever, like the problems that rspack faces, so like a lot of stuff at ByteDance is built in-house. And the main reason is because when we run into a problem, there's nobody we need to ask from the outside. And that can get a little crazy. Like, let's build our own JavaScript runtime. But ultimately, if the business needs a problem solved, you don't have there's no. It's yes, we have everything we need. But that said, there's still open source stuff we depend on. And so like a really big one for us is SWC. And that's one that is hard to get access to because it's largely like time, like KDY is like the main guy behind it. And if KDY doesn't have capacity to do it, we can't then it doesn't matter how many PRs you send in, you can't help coordinate with the author and cool, how can we utilize a mix of manpower and what did you want to do here and then combine to try and solve some of these issues. So we identified there's lots of common shared foundations in general that even if there is TurboPack here, if rspack is currently impacted by an issue in SWC, we know TurboPack will be as well. And beyond competing in the open source, because again, we don't have too much skin in the game in terms of we don't need anything from these tools. They're side effects of we have our own problems to solve, and by solving ours, they mostly work for everybody else. So here's a copy of it. So I think what was interesting is okay, well, we really admire TurboPack's work. I still am a big fan of Tobias and think the guy's really next level on bundler design. And I think a lot of my teammates would agree that yeah, he's the epitome of building bundlers. So I think it was just a really good opportunity of, well, one, we do admire the work that they're doing over there. The guy behind it, obviously, we're very happy with his prior art since we built our version off his design. So it seemed this would be really essentially, how does this become a rising tide lift all boats? We're happy to pass more of next test and try to get this thing into an upstreamable position. If we can also have a greater impact that solves some common problems we're having. So it's kind of okay, well, we don't really use the Next plugin, but it would be really great for rspack to be able to prove that it can build that. Obviously, that's getting a kind of informal blessing, on, hey, rspack's good enough to, we'll let it run on here. I think it was a big milestone for the project just to hit. But I think as well, one of my colleagues had said that regardless of any competition that might be between the two build tools, the fundamental layers there's so much more value to drive out of working together to fix those, even if we are never even if we're at odds with the top end build tool. If it comes down to an example was SWC used to have a kernel panic when you would have a chunk over 100 megs. Now that's probably not a case a lot of people run into, but when you run into it, you're kind of dead in the water. And so these were kind of things where we'd okay, well, we'd love to be able to fix this, but we need to kind of be able to collaborate a bit more. And so I think this just created a really good atmosphere where, yeah, we're happy to kind of help upstream this back in. Think it'd be great for the project, but we'd also love to not just, take the RS Next stuff, kind of sink a bunch of manpower into it just to get it onto Next.js. Again, we don't use it, so there's really not much use for us, but doesn't mean we wouldn't have loved to see it get in there. And also the way that it's done is really great. But I think the Next rspack is really just kind of a nice gateway piece of cool, through this we can now we now are supported Next 15.3, and I think the main thing is, but we are going to be working on shared problems that impact us both. So some big ones already, I would say largely around SWC again. I think since the past few months that we've been collaborating, we've seen the performance improve, just various reliability and performance improvements of SWC significantly improve essentially. And that's exactly what we want is if we know how to write the Rust code and what you want it done, then perfect. Is there a way that we can kind of work together on some of these things? So really, I think that's primarily how it came around is hey, could we upstream this? Think it'd be a great community option. I think the motivation behind it as well is just you have a situation where there's everybody who wants to go and use TurboPack, but a lot of the people who are on Webpack are usually the big, like, whoever's stuck on a Webpack build is going to be somebody who's worth like a lot of money, like company wise. Because it means that they've created this massive monster and it's not something that you can just rip out in a couple days and pop something new in. So if you're really coupled to these build solutions, I feel like in Next, it was also challenging because you don't have an option. TurboPack gets all the love, it's getting all the speed, and Webpack can't get any quicker. And so those users just don't get brought along. So it kind of is counterintuitive to like Next's good DX thing that it tries to promote is like, hey, it's nice to work with. But then it's like, oh, well, it's nice to work with only if you're in the club. But the Webpack can't be fixed, so your best move is to move the Webpack, and that's not a very nice thing to hear from like someone who relies on it. So I think this was a really good way where it's like, cool, people who can't migrate yet, perfect. Hey, and if you prefer the Webpack style convention, like maybe you want federation or things like that, here's a solution that at least now is going to be like fast or comparably fast to what you could get. So yeah, I think it really throws a lifeline to anybody who can't move. They can now get a nice DX improvement. We get a lot more, eyeballs looking at it, and obviously we get like the best battle test that we could want, which is against Next cells.
Yeah, it's cool to see more and more like shared foundations popping up between these projects. It just lifts all the projects up.
I think the big thing there is like it's surprisingly few people who actually like that own a lot of these libraries or something like the clusters of devs are really small, so it's really helpful when there's an opportunity to like work together because there's especially in Rust compared to JavaScript, it doesn't feel like you have the same like vast JS devs everywhere like when you go to conferences and stuff like that. Like Rust isn't quite there yet, so I do think it's probably best for those working in the language to try and work together if you're solving a shared issue, because really there's not as much manpower to stretch like you would have on NPM.
So before we wrap up, I think we should touch on a new project from ByteDance, Lynx. It looks like it's a React Native competitor. I think I saw some CSS in the docs. So could you explain to us what it is? And like, is it like a native renderer? Is it like a web-based thing? What's going on there?
Yeah, so Lynx is quite interesting. So originally it was built at ByteDance, and then TikTok is the one who's essentially the funder and the like main open sourcer of it currently. And I think the reason that we have Lynx is so I guess one scenario is like, remember when Facebook wrote React? And what was their first use case? It was the like button. And they wanted to swap out a like button in PHP somewhere. Now, I believe that is essentially kind of like how we like the reason that we use something like Lynx was, okay, well, we have a component that's maybe not worth writing in Swift or C. And bringing in React Native is potentially like too much overkill for this thing. So we need a lightweight solution that's relatively low friction. And then a big thing here is like everything here is web. Like it all looks web or is kind of, how do you make the web type experience show up in things that aren't necessarily normal web? Because I think just in China, everything's a lot more client-side rendered. So there's a lot more mentality around, okay, this is like how we kind of work. But it also just makes it familiar. So Lynx, some things that were, okay, so the first thing is, so Lynx is actually agnostic. So it's not like React Native, but it has React Lynx, which is essentially bindings to Lynx that give you JSX. So I think under the hood, it's technically using Preact, but essentially, here's like the lightweight React, like bindings to this, but you could also do it with Svelte. I think you could do it to Vue as well. And then I know I just saw they announced they're working on a vanilla one where, hey, you don't need any kind of UI framework and you could just use vanilla JS. So like, is it web? Kind of, but there's a custom renderer built into it. So a similar kind of thing where we actually render it down. So things like, I think you've seen we have like really good performance on the virtual list scrolling, or like doing all the weird, carousel things that are easy to do on web, but really hard to do in native. Like a lot of that stuff is also kind of baked into it. But yeah, like even when you style CSS, I believe that is converted. Yeah, that gets converted into like the native equivalent. So it'd be the same as like, I've never used much of React Native, so I don't know much of the styling semantics of it. But essentially, it's saying, okay, read this from your CSS and make that happen and create the final like rendered element styled correctly. We don't support all CSS selectors, obviously, but we support like a wide range of them. But I think ultimately the thing that we were after was we need a native solution that's fast, that's lightweight, that we can sprinkle into views that don't need all the effort or all like the hard work that goes into like making, say, the mainline experience. So I think like on TikTok, they were saying like the TikTok app is native, but the TikTok shop is Lynx or something like that. I'm not sure if it was the shop. Maybe it's the studio. I have to go back and read the blog post. I don't work on TikTok. I don't work for TikToks. I don't actually know, but essentially it's this idea of you have things that need to run super, super well, and you'll write those in native code. And then you have other things that are like, you don't need that much out of them, where a good kind of native but web feeling solution would be perfect to inject these things, like banners or certain pages that are, out in the flow, but maybe your main video scroller, keep that in C. So I think that was a lot of like what it was used for, like surgical ways to, make a app, have more features in app without necessarily having to commit to like the whole, like a all or none type of scenario. So I think that was kind of like some of the main reasons that we had done it was it was very like tactic, like, surgically inside of existing apps. We needed something that worked cross-platform because we have to deal with like a lot more devices as well. So we wanted, something that truly worked on everything, because we have so many like hard, I think, we even have like Pico, which is like VR headsets and stuff like that. So when you're thinking about, I need a cross-platform solution, the potential of the platforms you're up for consideration are beyond just like, oh, well, it needs to work on like a phone and a desktop or something. So I think that's where a lot of it came in. Now, it is still like in its early days and all of that, but it has been really exciting to see like what they're doing. And I think they would love to collaborate with like existing community. Like, I'm sure they would love to collaborate with like React Native group and stuff like that on, similar kind of thing. Hey, is there any kind of shared foundations that could be helpful to lift native app dev in general? But, that's I don't know if you have any other specific questions in there. I kind of got off on a tangent, but that was generally what Lynx was like brought to do in its current form, is like drop in there. What I would love to see is something like a router. I think that's like a missing part, but I also understand like why it's a missing part, because we're not like making your normal like router app where, hey, everything is React Native and it's all Expo or whatever. It's more like, we have a app that's built for this purpose, but this thing doesn't need to be in the same language because it's not as mission critical. Like, the manpower to write it in C isn't necessary. We could do it better if we wrote it in a more web-friendly language. And then that's also a lot more portable across a variety of platforms.
Cool. Well, it sounds like you guys are working on just so many different cool things. Like, we're out of time now, but we didn't even talk about all the different RS family members and all the different like permutations that you guys have come out with. So it's exciting to watch from the outside looking in. And thank you for building all these tools and for coming on.
Yeah, it was great. It was great to come on and chat.
Yeah, thanks again, Zach, for coming on. It was awesome last time to talk to you about all the module federation work you've been doing, and great this time to catch up on what the current state of rspack is. It's cool that you're breathing new life into the Webpack ecosystem. It's such an important ecosystem, and it's such a broad ecosystem. So it's great to see.
It's something that you don't want to see die just because like times have changed. And that was a big thing. Like, it would be really nice to just keep it alive because there's so many good things on there. It just needs to run quicker. I would say, like, I know we didn't get to the RStack stuff, but I think, like, in general, what we're just planning to do with our thing, with what we've got, is like, okay, as you can see, we're bringing out a lot of pillars of the infrastructure that we would need. That we're going to be bringing out tests. We already brought out library builds, like, unbundled, tree shakeable NPM package builds. We have RS build, which is the recommended way to use it, which is essentially our Vite. If you were to say rspack's the build engine and RS build's the Vite of the world. But, I think probably a lot of this is going to be how do we fill out that ecosystem to provide kind of, because this is from our own internal unified infrastructure kind of approach for everything. It just makes sense to build like this. But I think also it's something I would greatly appreciate in the open source space to say, hey, here's like a full suite of tools that I don't have to buy into all or none. But if I do want more, they're happen like, that it's designed to work together. And I think that's something we still struggle with in like ecosystem is the pieces can be glued together, but it's not necessarily like one shop saying, here's testing, here's docgen, here's bundlers, here's, frameworks, all the other bits and pieces, library authoring. So it'd be really nice to have like a single pipeline for building your packages, your apps, and like, everything else. So again, I think ecosystem as well. Users who want to use this, we want to make the ecosystem a bit more welcoming, bigger. And, I think that's also another key factor in like the future bundler wars is going to be, well, what kit does it come with? It doesn't really matter if the tool's good, the whole bot needs to kind of be there as well.
Yeah, there seems like there's a few different groups trying to hash out that battle. So I wish you guys luck.
Oh yeah. Anyway, yeah. So thank you for having me on. It was good to catch up after such a long time.